Hi, everybody. I'm Paul. I'm part of the Cassandra community, and we have a pretty exciting talk today. Let me share a slide here. Let me see. You all see my screen? Okay, great. So we've got John Haddad, Dinesh Joshi, and Vinay Chella. They're going to be talking about Cassandra 5.0 for AI and ML workloads. Do a few community announcements. So upcoming event, we've got Maxim talking about SEP 38 and CQL management. So that's going to be next Tuesday on January 30th at 10 a.m. Pacific time. So you should definitely come check that out. And then if you have something interesting you want to share, a use case, or if you want to speak at one of our contributor calls, you can reach out to me. We can set that up. All right, great. So I'll stop sharing. I'll hand it over to John, who'll be moderating discussion. And if you have questions, feel free to just put them in the chat, and John will be moderating those questions throughout the conversation.
Yeah. What's up, everyone? Thanks, Paul, for having us on.
Yeah.
So just a heads up, everyone, my voice is a little sore today. I'm not sure what's going on, but I may be speaking a little bit less enthusiastically than I normally do. Just, tone will be slightly lower, but I'm still here with the heart, just so you know. So yeah, let me bring up my slides and let's get into the mix, huh? Cassandra AI Town Hall. You see that okay?
Yeah.
All right. So this is going to be a little bit different from how we've run some previous uh, events. We do have slides, but the slides are not uh, really kind of driving the content. This is a discussion. We're basically using the slides here just as sort of a framework to move our conversation along. And we're going to start by taking a look at kind of the landscape of AI, make sure that everybody's familiar with some of the fundamentals that we're going to be talking about. Just some, we're not going to go into crazy detail on this, but we definitely want to make sure that if you're not familiar with AI already and kind of the landscape of what it looks like what people are doing with it in general, the capabilities that it has, the terminology. We just want to make sure that everybody's is up to speed with that, and then we can kind of dig into some of the particulars about Cassandra and things like that. So let's get it going. The world of AI, we're all excited about it. I know that it's one of those things that I was uh, blissfully unaware of how advanced it had become in so many different areas. And, recently, I think that especially with OpenAI, if you follow the news with OpenAI and watched as this thing becomes like this massive hype machine and looked at Midjourney and all these other tools that have come out, if AI wasn't on your radar before, it definitely should be now. And so with the Cassandra 5.0 release, we're really excited to be able to provide support and functionality that is really really helpful in the AI ecosystem. Because the reality is it is hot right now. Like there's like a billion job openings for people that know AI stuff. So if you know this, you're definitely going to be in a good position later on. So let's get into some of these ideas. As I mentioned, like OpenAI and Midjourney, these are generative AI bits of functionality. This isn't the only thing that we would consider to be like in the machine learning AI camp. It's just the thing that has gotten the most like press right now. But the reality is that machine learning has been around for a long time. This is not a brand new. This is not a brand new idea. And I know that Vinay, you're going to have a lot to say kind of about Netflix's use of machine learning over the years. We've worked on some of that stuff together, and it's pretty cool. But right now, this is where all the hype is. So one of the things that you'll hear a lot about in the area is that Cassandra is going to be able to get involved with in Cassandra 5 is this idea of an LLM, or a large language model. And basically what this is a new type of system where instead of having to learn like SQL or some other language and like figure out like how the computer uh, wants you to talk to it, you can just talk to it in your natural language because it's been trained over these massive data sets of of, of text, whether it be Wikipedia or just New York Times, which they're now suing OpenAI, or really kind of anywhere. You can feed in arbitrary data sets to it in any language, and it can learn the relationship between words. And that's really powerful. There was a paper that came out in 2017. I think it was called Attention is All You Need. And it basically is the foundation for which these new LLMs are able to be built. You may have heard a term about hallucinations over the years with AI, and you ask a question of a large language model, and it gives you back some uh, crazy response that has nothing to do with what you asked, or it's sort of related to what you asked but isn't really. And this is kind of one of the areas where Cassandra is going to be the most helpful. So I think that this is a good time to introduce retrieval augmented generation as a concept, and we'll just refer to it as RAG. This is where we're going to stop and just kind of talk a little bit about kind of the state of the ecosystem. Vinay, I want to ask you, what has your experience been using these tools, either through as a user, or I don't know if you've seen any of this stuff internally over at Netflix. Like, I don't know if you could talk about it. What's kind of what are your thoughts on the state of this concept?
Thank you. Thank you, John, for bringing the discussion and talking about use cases that I've been working with, that I've been seeing, especially in the area of machine learning. As you alluded, machine learning is not something that is started now, or any of these AI or machine learning models is not a new concept. But I think with the generative AI, it has gotten more traction. But it is important for us to go back to a decade ago and talk about all the refer to all the advancements that have been happening in the ML models, like specifically within the ecosystem of Netflix, and within the ecosystem that I'm working in. These ML models at a large scale have been in use for over a decade, and especially with the systems like Cassandra, which is almost like bread and butter for Netflix. How Cassandra has been being the Cassandra has been the store to store all of these trained model data, and bringing the trained model data for online systems to be able to surface it through Netflix application, Netflix service for our users, has not been something new. And that is where I think all the advancements that have happened in Cassandra and that are happening in Cassandra would be would elevate how data scientists, how software engineers are working with these large language models, how they are interacting with these large language models. The productivity, all of those, we'll certainly talk about in detail, specifically the specific features that are coming in Cassandra 5.0, and what are the things that I'm looking forward to, and how they are going to change the lay of land for especially ML and AI workloads.
Dinesh, do you have anything to add?
Yeah, I mean that's so retrieval augmented generation is just for folks who aren't familiar with the landscape. I'm no expert in this landscape either. but it is basically enrichment of data, through enrichment of your machine learning models responses through, look-aside data that can be used, which is domain specific. Yeah, that's a great example of what it is, right? And in the machine learning ecosystem, these databases of information is required, and Cassandra offers to be a good foundational piece in some of these ML systems that you can rely on and scale.
Okay, let's take a step back and talk a little bit about some of the interesting bits about LLMs that are different from some of the ML workloads that we've had in the past that you were mentioning, Vinay. So one of the really interesting things about this is that uh, LLMs are essentially trained on using something called deep learning. So deep learning is a type of neural network. For those of you that don't know, neural networks are composed of multiple layers. So you've got an input layer where you have your the data that we're feeding it, and then you have the output layer, which is just the result of whatever it's doing. And so deep learning basically has a bunch of layers kind of in the middle where we're feeding in data and they're constantly adjusting the relationship between the nodes on the inside of the network. And you can think of it as like basically an attempt to model the human brain. And we have different strengths between the different layers and the different nodes in the layers. And that allows us to give it sort of these arbitrary data sets, and it's able to essentially adjust itself to be able to output answers that are reasonable for all those inputs that we've gotten. So there's some supervised learning that's used to make sure that things are like outputting good results. But it's a little bit weird in that like you don't have to make specific rules about the relationship between things. You can just feed things in. And this comes back to the hallucination stuff that I mentioned earlier. So one of the problems with a system like this is you can end up asking a question that's really vague and getting an answer back that has nothing to do with what you were asking. And this is where RAG is really helpful. And this is actually one of the areas where Cassandra is going to be really useful, because these deep learning models are not actually being run on Cassandra. We need to run them on GPUs. They are too intense to have the overhead of going to a database right now. So essentially what you have is this LLM. And if you look at the slides I have here, we have, I think this might be like a Santa Claus on the right. I'm not really sure. It kind of looks like it to me. Asking a question, that's the user prompt. And then we do something, we get additional context. So in the context of like, let's for example, say that we have our Cassandra documentation, which has recently gotten a huge amount of contributions to it. It's really exciting to see the docs be at the state that they're in. If we were to take all of our documentation and index it in a database like Cassandra, and then ask a question to the LLM, we can actually pull out relevant documentation out of the Cassandra docs, feed them into the LLM for context, and then the LLM is going to give us a response that's much more accurate for what we're asking it, because we're asking questions about Cassandra. It has access to the Cassandra manual. It's going to do a lot better than if it had access to Wikipedia. There's just no reason why it needs all the like historical information that's in Wikipedia. We use the context of the Cassandra manual to help guide it to get the right answers. So that's where we can talk about Cassandra, the actual technology that powers this. You may have heard about vector databases. So vector databases are really interesting because internally, the models in the LLM, the text that we're sending into it, this is actually being represented not by all of the text, but by these vectors. So we're turning text into vectors, which is basically a series of numbers, It's a series of floats. And if we are able to turn documents into vectors, then we can do something called a vector search. So a vector search allows us to find similarity, and this is where Cassandra, the upcoming functionality, Cassandra 5, is going to be really, really, really helpful. Vinay, do you want to maybe talk a little bit about the upcoming vector type and kind of how it gets used?
Yeah. So thank you, John. When you think about vector, so I'll take a step back and try to build the connection from how do we even get the vector data. So when you're talking about the example that John has taken, taking Apache Cassandra documentation and giving it to the LLM model and asking the questions about specific thing, and then your models giving you the results. There are several techniques that are being there are several things that are happening here behind the scenes. All of these data that is being fed into is being converted into what is called as vector embeddings, right? So vector embeddings capture, basically these embeddings capture the relatedness of, let's say, in our example text. They basically, these embeddings make it easier to do any of these machine learning or large inputs, like we are talking about a lot of words, and converting that words into embeddings in a more mission understandable format is what these vectors basically do. So they are basically floating point numbers. It Ideally, any of these embeddings would capture some of the semantics of all the input that is coming in by placing semantically similar inputs closer together uh, in the embedding space, and that's where our Cassandra comes in place and would be helpful. I mean, with the introduction of vector data type, we would be able to solve the applications in the search, where basically we can, results are ranked by relevance, clustering, recommendations, anomaly detections, or basically classifications, right? So um, as you can see, in the last 1 to 2 years, there have been many databases out there which have introduced the concept of vector search in their systems. But I think what keeps Cassandra on top of the list for me is several things. So when you think about vector indexes, there are many standalone vector indices. Like, one of the famous thing that comes to my mind is Facebook AI similarity search, which can, basically improve the search and retrieval of all these vector embeddings that we're talking about. But any of these standalone indexes, like vector indexes, lack the capabilities of, a standard cloud scalable database like Cassandra. And here is why, for me, Cassandra would be in the top list among all the things that have come up in last 1 to 2 years, is because of following. One, um, data management. So as the data is growing unboundedly with all of this usage of AI, Cassandra is fundamentally designed from the ground up to scale linearly as you add more nodes. These standalone vector indices might suffer at that. But when you think about vector database, and I mean, in this case, I'm talking about Apache Cassandra with the capabilities that have been introduced in 5.0. And then scalability is what we're talking about. And then the real-time updates, like being able to, read your writes with the consistency tunables that you're comfortable with versus what the standalone vector search systems are giving. Like, for example, if you take Elasticsearch example, it depends on the flush intervals, it depends on the index intervals. But when it comes to Cassandra, all of these guarantees are something that you can configure and tweak based on your use case. So you don't have to bend your use case for consistency guarantees. And then Cassandra, always on capabilities of Cassandra also make your AI systems, which are depending on this data, for any of the use cases that we're talking about, like to reduce the hallucination, searching, clustering capabilities are always on without having to actually take a downtime. Then all the data security, backups, restores, all of these systems, I'm sure in an ecosystem that you're on, where you're using Cassandra, all of these systems have already been built where, you're regularly taking backups, you're regularly auditing your systems and stuff like that. But with Cassandra 5.0, you don't have to introduce a new system into your ecosystem. With the Cassandra itself, you can get the capabilities of, vector search on Cassandra without actually having to build the whole 9 yard. And that's where I talk about it as an ecosystem integration. You don't have to, bring something new.
Yeah.
Data security and access control is another thing that comes to my mind, which has been the front runner for Cassandra, at least since 4.0. We've been focusing really heavily on the security and access control. So all in all, with the introduction of vector type that you are seeing on the screen in 5.0, this makes my favorite vector database that I would choose when I'm building any of these LLMs and any of these generative AI applications.
Yeah. Yeah, I think there's definitely there's a lot to be said for not having to learn yet another system, especially one that would be specialized, like an entire database concept centered around one feature. That's, to me, that's not that appealing. Like we don't have separate databases for looking up, one record versus 20 records. Like we really ideally have great indexes that allow us to kind of search for all sorts of different things. I think that's one of the reasons why I think one of the things I think is really interesting about this is that the vector stuff is built on top of it's built with SAI, which is the new index feature that's coming in Cassandra 5, and this is definitely this is a game changer. Honestly, I think that this is going to enable a lot of different types of query patterns. It's going to change the way that we think about data modeling. Dinesh, I know that we've talked about SAI before. Do you want to maybe talk about this for a minute and like kind of some of the things that SAI will enable us to do and kind of how it relates to vector?
Yeah. So actually, I wanted to talk about vectors for just a second. So agreed with everything that Vinay and you guys have said. One unique thing about Cassandra's implementation of the vector search is basically it inherits from like the Lucene. Lucene has a library which is used for vector search, and with Cassandra, there is some changes that were made to make it even more real time and performant. So with Lucene, there is like when you insert records, vectors basically, there is a delay in indexing those, which doesn't exist in Cassandra's implementation. So these are subtle but meaningful differences when you're building a system. You don't want to insert a bunch of records and then wait a while for the system to index, and then you can the data becomes available for you to search and retrieve. When things are being built at scale, these are differences that make a lot of sense. And that's the whole point of embedding something like a vector search in Cassandra as well. So as you said earlier, like moving to SAI, SAI was introduced in Cassandra as a 5.0 feature. vector search is built on top of SAI. And Cassandra has historically had many 2i implementations. I wouldn't call it many, but this is the third iteration, I would say. Interestingly, Cassandra's first implementation had many restrictions. It didn't support, OR queries, or you had to match exactly the predicates, which solved for some use cases, but not all of the use cases. Then there was a implementation called SASE that exists in Cassandra, which improves on this, makes it more scalable. And then SAI is the third iteration, and SAI is a fundamentally different implementation where the index is attached to the storage, which means that it is a component in the SS table format. And that gives it a lot of leverage or advantage that we have that we wouldn't have with other indexes, which are distinct and separate from the database. You have to worry about keeping things in sync. You have to do the all rights and those type of things. SAI is a very flexible way of indexing. From a efficiency standpoint as well, there were some comparisons that I saw for let's say about 100 gigabytes of data that is indexed into the database. SAI's efficiency is dramatically good. So it occupies much less space compared to the original 2i implementation and SASE as well. So SASE is a little bit, I believe that they are pretty much the same, the original 2i implementation SASE in terms of efficiency, but SAI is dramatically more efficient than the other implementations.
Yeah, the original secondary index implementation was essentially just a table. It was a hidden table. You didn't get to see it. It was slightly more convenient than managing two tables on your own, but you end up with a bunch of like hidden gotchas. I think in a lot of cases, people were really taken by surprise at some of the performance issues that come up with secondary indexes, and I think that SASE, to your point, was a huge step forward. The idea of storing the SS tables alongside the indexes alongside the SS tables is really great. There's a number of reasons why it's advantageous. There's some things that it won't work as well for. But I think for the cases that we're looking at here, the problems that we want to solve, it makes a ton of sense. Vinay, do you have anything to add?
No, I think Dinesh, you covered the both history as well as what is coming in 5.0. And I would tie it back to the performance again. And we quoted some of the optimization examples, vectors being built on top of the strong foundation of Cassandra, strong foundation of SAI, makes it much more compelling and much more, selling. The selling story is pretty strong for us to use the vector feature in Cassandra 5.0 with these strong foundations.
So one of the things that we kind of touched on already is the why Cassandra. I think especially for folks that are already using Cassandra, to me, it's a no-brainer. It's just like, we're not going to have to set up an additional thing. We already like that we can run in multiple data centers. Like, we've all, we've seen the benefits of running multiple data centers in multiple continents. Like, it's a huge bit of functionality that I think that everybody else kind of uses as an afterthought. To me, that's one of the primary benefits of using Cassandra. It's one of like the strengths of its architecture. And I think that not having to figure that out again is great. And I think that not having to, like Vinay, I think you mentioned, you already have a backup system in place. You don't need to reinvent backups for some other database. Like it's really like if you're already using Cassandra, to me, and you want to use some AI components, to me, it makes a lot of sense. I want to talk a little bit about some of the use cases here that we have, the emerging ML use cases powered by Cassandra. It'd also be nice to kind of take a look. We mentioned before about some of the older, the things that aren't LLMs, the things that we can use Cassandra for today. Vinay, do you want to maybe talk a little bit about some of the existing, a little bit more about some of the existing use cases that you use Cassandra for?
Yeah, certainly. I think one major use case that comes to my mind is version dataset. Especially in the field of data science, machine learning, and AI. This is a common term that you use. And I'll give a really brief introduction of what it is. A version dataset, basically a collection of data put together, where the different versions of data or different iterations of the data is systematically being tagged and managed. You'd be able to tag your entire database or the data set and version it. You can think of it as like a snapshot of a data in point in time, where it has the capabilities to capture the changes, updates, and modifications made to the data. So, and why is it important in the field of data science, machine learning? Is because the concept of reproducibility, right? Especially in the machine learning field, where we are, like specifically in the case of, let's say, Netflix, where we are generating a homepage, where we are trying to understand how you're watching the movies, what you like, what you don't like, and trying to generate a new homepage for tomorrow, so that when you open Netflix, you don't have to spend too much time figuring out what to watch. What you would probably watch is already on your homepage, and with a few clicks, you are into the movie, into the show that you would most probably would be watching. But it comes with a lot of experiments, right? So sometimes some theory or hypothesis that we are thinking of might work, and sometimes it might not work. Having these version data sets enables our data science teams, our experimentation teams, our software engineers, to be able to tag the data set and experiment with it. And if the experiment turning out to be good, then we'll be productionalizing it. If the experiment is not yielding good results, then we will not be productionalizing that model. So at any given point of time, there are tons of models that are being experimented, there are tons of data sets that are being worked on to produce what our customer likes. Having this version data set is the only way for us to make our experiments much more faster, easy to iterate on, right? So having that reproducibility and auditability enables all of these data science teams to move fast. And Cassandra is the place where we use, today we use Cassandra for us to keep these version data sets and to be able to iterate on these version data sets. And in Cassandra 5.0 with CEP 28, if you have read that CEP, it talks about easily exporting and importing petabytes or terabytes to petabytes of data out of Cassandra in a much more scalable fashion. And that, today we are using Cassandra already, but with the introduction of CEP 28 that is coming in Cassandra 5.0, it makes our job, all the tooling and ecosystem integration that we build, much more easy, much more simple, with the basic features that are coming in Cassandra 5.0. It also enables us to collaborate with the different teams, like where data scientists will produce a model, will tag a data set, we'll hand it over to a different team to be experiment with it, and where multiple team members would be able to work on the same data set with different experimentation, different models. It also improves the overall development workflow, as I was alluding to, and it makes training, deployment, and development much more efficient.
The
But I think
yeah.
that I'll add one last point there,
Yeah.
which is very important in the recent days, at least in the last few years: compliance and governance. We would be able to track back what we have shown it to the customer, how we have shown it, how did we end up showing what we showed. Having these version data sets allows us to draw this data lineage on how we trained a person's data based on their, let's say, viewing history, based on their purchase history in a typical e-commerce, why we have shown a certain product on their homepage or certain movie on their homepage, and how did that yield in our ROI, our click-through rate and stuff like that. Being able to have that data lineage, build that lineage, helps us make our product better, also addresses the compliance and governance needs that are becoming more and more important. So that's what one major feature that I'm really fascinated by, which I'm super happy and excited to deploy Cassandra 5.0 in our systems and being able to use that CEP 28.
So on the topic of CEP 28, the title of that is Reading and Writing Cassandra Data with Spark Bulk Analytics. This is Vinay, as you mentioned, this is a new functionality. Dinesh, I know that you're pretty familiar with this idea. Would you like to maybe kind of talk a little bit about the Spark Analytics stuff and maybe how it actually ties in, like how this is going to help make Cassandra better for ML workloads?
Yeah, I think we did cover this in a previous town hall, if I'm not mistaken. But we also talked about it in the Cassandra Summit. Basically, with machine learning, we need a lot of data, right? So we started talking about the whole ecosystem as such, right? And Cassandra is typically used to store a lot of data. And so when you need to process that data or use that data in building machine learning models, or you need to use it in data pipelines where you're extracting features from the raw data that exists in your Cassandra cluster. That cluster can grow very large, the data set can grow very large, and the existing mechanism to pull that data out is using the Java driver. And don't get me wrong, Java driver is really good at pulling data out one record at a time, or even several records. But when you pretty much want to read the entire data set out, it is not practically feasible. For small data sets, you can do it, but for very large data sets, say 100 terabytes or so, it'll take a very long time for you to scan all of the data. Cassandra is not built for such use cases where you scan all the data and then read it all out. So CEP 28 brings some of those fixes. What we've introduced is a library and a sidecar component. Sidecar pre-existed. The library called Cassandra Analytics Library is a new library, and it's specifically meant for reading this data out in bulk. And typically, if your use case requires you to read all of the data out, and then you have a big Spark data frame that you want to then manipulate and you want to run some queries on, then the Spark Analytics, the Cassandra Analytics Library allows you to do that very efficiently. So the key here is that we don't impact your production SLOs in any meaningful manner, because the SS tables are streamed directly out of the cluster into Spark, and then in Spark we join all of the SS tables, deduplicate data, compact it, and then provide you with a data frame. So that is if you want to build features, right? On the other side, like there are a lot of use cases where raw data exists on HDFS, S3, or other such data stores, And we have use cases where all of this data is processed in a data pipeline, and you extract features, and then you need those features for inference or further training of those models. And so what you have is a problem statement that your data pipelines need to push a lot of data into Cassandra very, very quickly for serving those features to your machine learning models. And this is the other side of the coin where you need to push a lot of data into Cassandra. And the bulk analytics CEP was basically meant to solve both of these use cases. This is like the short version of what my talk was earlier this year or last year.
Nice. Vinay, I know that you had a little bit that you had in mind about when Dinesh mentioned feature stores, or when Dinesh mentioned features. I remember we talked about feature stores a ways back. Did you have anything that you wanted to add about that?
Yes. I'll talk a little bit about feature stores and hand it over to Dinesh on that. Specifically on the in the machine learning models, if you think about training a data set, it requires a lot of dimensions. If you're talking about a customer, it requires a lot of dimensions about customer, purchase behavior, customer, let's say, what are they browsing, their location, their behaviors and stuff like that. And as in when we are as we are making these models much more rich, the number of dimensions that are being considered in training these models have been increasing. And in the concept of data science, that models is also being referred as like features. And the feature store is a place where you would be able to store data related to a customer, data related to let's say a product or a movie, and being able to use it much more at a very high frequency to train the model and to produce the model that you're actually looking for. And Cassandra is heavily being used as a feature store, um, you know, across the industry, just because of its performance, just because of its scalability, right? So you'd be able to quickly scale the feature store to be able to store, let's say, 100 dimensions, from 100 dimensions to 500 dimensions, without actually having to slow down your development velocity. And I think that's also another use case with the introduction of LLMs and generative AI, catching up, catching the velocity and momentum that we are seeing. I foresee Cassandra will be used as one of the major feature store as well. Dinesh, do you want to add anything on?
Yeah, so taking a step back, feature stores are becoming increasingly common. There are like purpose-built feature stores. It's not just a simple database anymore. It is an entire ecosystem where data scientists are writing code to actually extract features from raw data, and then that gets populated in a data store like Cassandra. So Cassandra is a natural choice. Like we've, I think, said a number of times that if you have Cassandra in your ecosystem already, it doesn't make any like business sense to take on another database, another system, just because it has a unique feature, because that increases your overall cost of maintenance and all of that deployment. So yeah, I know you were talking about cost considerations, but this is a relevant factor in considering, right? So with feature stores, Cassandra is something that can be used to share like higher order data, like the features that are extracted from raw data. And essentially, a lot of times features are just vectors or a time series of vectors. So Cassandra is very good at these key value use cases, and it has also with time windowed compaction strategy and those that its existence in Cassandra is basically very much geared towards if you're capturing a trend of any metric or any feature, you can use that to efficiently store a time series of features. So all of these are very much required by machine learning models, and so Cassandra falls into that bucket of your natural choice to back a feature store with this database.
So one of the things I want to be make sure that we're aware of is, just in case there's any questions that pop up, I want to make sure that we leave a few minutes. As you saw, I hit my scroll wheel and moved us one slide. Oh God, which way is this going? Cost considerations. There we go. So one of the things I want to talk about is cost considerations, because this is a big thing, right? Like it doesn't matter if we have the greatest database on the planet if it costs too much to run in a practical situation. On the topic of vector and kind of all the generative AI stuff and how we're going to use it for RAG and storage of the original kind of text data and prompts and history and all the cool stuff that we're going to want to use this for. And I'll, either of you can chime in here. Feel free to jump in. But what do you think are some good cost considerations? What advice would you give for folks that are going to kind of go into this? Be early adopters. Like what would you recommend?
So this is a topic that I have to deal with on a day-to-day basis, so it's very close to my heart. Just very briefly, right? Like if you take a step back and look at the evolution of Cassandra as a database, it's been around for, I want to say, 13 years now. This could be the 14th year that we are around, and at the 10-year mark, you kind of see a database starting to mature. In the big picture, databases don't move very quickly, but it's been an interesting journey for Cassandra. That it's been in the last 4 years that we have seen an accelerated development of features and which are kind of very much at the bleeding edge of the technology, and with those comes like cost considerations, right? Like Cassandra has evolved to be a very feature-rich database, but also very efficient, right? So there are so we introduced things like zero copy streaming that made it much more easier to replace nodes and make the database more efficient and elastic. And then with the introduction of bulk analytics in CEP28 and things like SAI, things are getting more and more efficient in various components of the database and allowing you to glue Cassandra basically to the ecosystem around it, like Spark, Flink, and those type of things. So we also had an experimental implementation of witness replicas in the database, which is also going to save cost. And so Cassandra as a database has become more and more efficient. And as we've seen data growth in this industry, like a phenomenal amount of data is being pumped into databases these days. It's very important that the system that we are using is efficient, right? And one classical example that I give is a lot of times people had to take data from, let's say, HDFS, put it in Cassandra through some Spark pipeline, and perform some ETL, and then that data gets ETLed into another database. But if you want to analyze that data, you have to again dump it back into HDFS, and then you can run Spark queries on it. That used to be the state earlier, but again with bulk analytics, you don't need that step of putting data back into HDFS. What you can do simply is use Cassandra as your backing data store, and you can just analyze data in Spark by streaming data out into Spark without really hitting that intermediate HDFS store or S3 store that improves your performance, and also it improves your cost factor. So there are many things about Cassandra that have changed over the years to provide cost efficiency.
Yeah. On that topic, there's a couple things that I would like to add is with Cassandra 4.0, with the netty internode communication, we also have seen tremendous saving in the CPU that is being consumed. As a result, you don't have to scale out, not just for data, but also you don't have to scale out as you increase the number of operations, like be it read or write or replications or repair. I think +1 to, all the, if you look at the 10-year mark, if you look at the latest, last 4 to 5 years of development and focus that has been happening in Cassandra, a lot of it is also around performance optimizations, which, directly correlates to cost.
There's also Z standard, right?
Yeah.
I called Z standard introduction of Z
Compression.
standard compression has also been super helpful.
Oh, speaking of which, unified compaction strategy that is coming in 5.0 would also make you not have to leave too much room for compactions. Space for, buffer for compactions as well. We can continue to pick each of these features, as I said, I think last 4 to 5 years of effort has been doubling down on optimizations, which directly helps us save cost.
So since we're just about out of time, we have about 1 minute left. I'm going to add in my own piece of advice, and then I think we're going to hand it off to Melissa. I think she has a goodbye message. So my tip is, if you are going to be using Cassandra and try to get some ML stuff in there and mix it with other different workloads, don't be afraid to run multiple clusters. There is a really dangerous. There's a silly idea that you need to put everything in one huge cluster and just keep growing it and growing it and growing it. Don't do that. Set up your infrastructure from the beginning so you can run multiple purpose-built clusters to solve specific problems. It is a really great way to keep your costs under control. When you decide to start adding AI, whether it be through vector or using Spark bulk analytics and processing everything in there, make sure that you're thinking about the different kind of workloads that you're going to run, how they're going to interact with each other. Because if you don't, you need to provision way more machines than you would if you just had separate clusters. So if you're going to do a vector thing, maybe it's a 3-node cluster. If you're going to do Spark, like really, really heavy Spark usage, you might want to have a separate DC for that. But you don't necessarily need to have a separate DC for all your data. You just need to have a separate DC for the analytics data. So it's a really good idea to just kind of plan things in advance, make sure that you're ready to run multiple clusters. And I think that if you can kind of tie in everything that we've been talking about, you can really be successful with Cassandra as your database that is kind of the central thing that everything is working with. So on that note, I'm going to just turn it over to Melissa.
Awesome. Yeah, no, thank you all for joining. I'm stepping in because Paul had to step out, but thank you all for doing this. This was such great information. Everyone, just to remind you, 5.0 beta is out now, so you can download and try it. If you have feedback, the community would love to hear, so please share on the mailing list and let them know. And then next Tuesday, we have the contributor meeting where we're talking about the CQL management feature that's being discussed for Cassandra, which you can find on the meetup page. So we hope to have you join then as well. But thank you all. Really appreciate it. Vinay, Dinesh, John, thanks for joining.
All right. Thank you.
Thank you.
Thank you.
Take care.
Bye, everyone.
Bye-bye.